Isolating terms in a formula. Here we have a formula a equals 4 times pi r squared, and we want to solve for r. Now, what's keeping r from being isolated is the 4, the pi, and the square. We're going to get rid of the 4 pi first, and note that they're multiplying. So the way to get rid of multiplication, or things that are multiplying, is to use division. So using division to cancel out the 4 and the pi means dividing by 4 and pi. And that will cancel to a 1. What if you do on one side of an equation, you also do on the other. So you put another dividing 4 pi here. So we end up with a over 4 and pi. These two cancel, and you're left with r squared. Now, to get rid of the square on the r, we need to take the square root. A square root will eliminate the square, leaving just the r. But whatever you do on one side, you also do on the other. So on this side, the square is eliminated. We're down to r. But on this side, we're left with the square root of a divided by 4 pi. Here, a equals a little a plus b plus c, all divided by 3. And if they use a capital and a lowercase, these are two different a's. Now we want to isolate for c. So let's go a equals a plus b plus c over 3. Now what we have is several things. We have adding here, adding b, adding c, and a dividing 3. We want to get rid of the dividing 3 first because this bar right here is dividing everything. So we want to get rid of the 3 first, or the dividing 3. The way we get rid of a dividing 3 is by using a multiplying 3. So I'm going to put a multiplying 3 over here. And let's put a multiplying 3 over there. Now, 3 times a is written as 3a. But multiplying 3 and dividing 3 cancel, leaving you with a plus b plus c. Now, I have to get rid of the adding a and the adding b. I think I said b and c before, but adding a and b, so we isolate the c. The way that we do that is that we put a subtracting a and a subtracting b. These will cancel, leaving the c. But whatever you do to one side, you do to the other. Now, none of these are like terms. Therefore, they cannot subtract or add from each other, or they cannot be combined. So we're just going to simply list them. 3a, a subtracting b, and then the equal sign, and then finally the c. And that's it. Next, we have another formula where a equals k times the quantity b minus c plus d. And we want to solve for this b right here. So we have to get rid of the subtraction, the adding, and there's multiplication. Now, who do you get rid of first? The multiplication, because this is multiplying by the entire term. So we're going to get rid of the multiplying k first. So a equals k multiplied with b minus c plus d. And to get rid of a multiplying k, we're going to use a dividing k. And those two are now going to cancel. Whatever you do on one side, you also do on the other side. So I put another dividing k into the a. So these two k's are eliminated. And you're left with b minus c plus d. And over here, you're left with an a divided by k. Next, we want to isolate the b, so we want to get rid of the subtracting c and the adding d. The way that we're going to get rid of the subtracting c is put up adding c. This will cancel it. And how to get rid of the adding d is put a subtracting d. Now, what if you do on one side, you do on the other. So put adding c here and a subtracting d there. All right, so to the next step. All right, these 3 terms are not like terms, so they cannot be added together. So we simply stack them next to each other. So I'll put first the a divided by k. Then I'll put my adding c, then my subtracting d. Now, and it doesn't have to be in this order. Okay, as long as the C is positive, the D is negative, and the AK is going to be positive. Now what's left on this side, once these two go, is just a B. And now we have solved for B.